Hello, I'm Junyan Chen. Today, I'm going to introduce some Chinese mathematics um, till 300 AD to you. So first, let's look at what am I going to talk um, in this presentation. First, I'm going to talk about some um, decimalism and the count method in ancient China. And then I'm going to talk about nine maths, which is um, nine branches of mathematics. Uh, then I'm going to talk about the book, which name is Nine Chapters on the Mathematical Art. In the end, I'm going to talk about Liu Hui, and that will be the end of my presentation. So first, let's look at it. Decimalism and count. So in ancient China, people use decimalism. How do we know that? Because people found some marks on bones, and on those bones, each symbol has less than 10 marks, which indicates that ancient Chinese use decimalism. And those bones were uh, from Shang Dynasty, which is like 1400 BC. And it's tightly connected with the counting system in ancient China because, as we can see in the picture on the right bottom, we can see that for number 1, 2, 3, 4, 5, people use 5 lines to, people use 1 or 2 or 3 or 4 or 5 lines to indicate those numbers. And then for 6, people use 2 lines which are in different direction, or we can say which are perpendicular to each other. And then we know that it's 5 plus 1, which is 6. And for 7, that's 5 plus 2. For 8, that's 5 plus 3. For 9, that's 5 plus 4. And then there's no a single symbol for 10. So how do people indicate 10? People just put one stroke representing 1, and then people left a space on the right of the stroke. So in that way, people can express 10. Also, in ancient China, people have the concept of 0, but people do not have a symbol to indicate that. So when we need to write 0, people just write nothing. They just leave a space after the number before 0. And then it's 9 maths. So during the Warring States, which is around 300 BC, people have already divided the math study into 9 branches, and they are field measurement, like people need to measure those fields so they can distribute their labor or profit from the field. And grain conversion. So in some area, people use one kind of grain, but while in another era, people might use another kind of grain. When they need to exchange them, they use grain conversion. The third one is distribution of taxes. So the government need to uh, get taxes from people. So it just happened. Um, the fourth one is field area length and width, which is very like to the first one, but it focuses on the area, the length, and the width of the field much more than the first one. The fifth one is earthwork. So when people building some, when people build something like bridges, like buildings, um, they need to do math like how much dirt or how much wood would they need for this building. That's called earthwork. Um, the sixth one is distribution of fee in transportation. Um, so when people have food, have grains, or when people have dirt, have woods, they need to get them transported. So that uh, that was connected to some fee. So people need to uh, plan on their fee of transportation. The seventh one is equation, just like the equation we are learning nowadays. Um, 2x plus y equals to 1, like that. Um, profit and loss. So it's like it's more used in business. And the last one is Pythagorean theorem. That's really an old and classic one, and we have also learned that uh, earlier this semester. And we can say that in the warring states, um, which is relatively early, people have already divided math into 9 branches, and then there is a book called 9 Chapters on the Mathematical Art. Oh, so we have 9 branches. Then it's it's really easy to think that math is consisted of 9 parts. So here we have the book 9 Chapters on the Mathematical Arts. So it's a book which is like a summary of ancient math research before 300 AD, and people start writing that since 200 BC, and it was done in 300 AD. It was noted, re-edited by a lot of different mathematicians during that time. Um, Liu Hui is one of them, who we will talk later in this presentation. And this book just sort all math problems into 9 kinds, and there were 246 math problems in this book, and 202 math problem solving methods. Um, many of them are still used in Chinese primary school teaching because some of them are really easy for people nowadays. But there are also some really interesting and hard in this book, and it's worth people thinking that deeply. So this book is like a conclusion, or it concludes of the Chinese math before Han Dynasty. Uh, Han Dynasty is like 300 AD. And this book is well sorted. It was sorted from easy to hard, and later it became a really good textbook for Chinese, like uh, in Tang Dynasty and the Song Dynasty, which is like 1000 AD. That is after 700 years since the book was finished. So it was really well inherited and widespread. Um, Even today, we can see some problems in this book. So it's well inherited. And it was widespread because later, like the 15th century, it went to Japan, it went to India, and people also like exchange their knowledge and got a lot from each other. So today, when we try to research back those math histories, we can see that uh, at some point, these knowledge are really alike. Uh, we have to admit that some of them were exchanged so they were alike, but uh, some of them doesn't have any connection before. They just came up with those thoughts magically, but at different places, at different time, without any communication. So now let's have some let's have some talk on Liu Hui, who is a famous mathematician in the Three Kingdoms period around 250 AD. And as I mentioned before, he noted the 9 chapters on the mathematical art, and he was like the last one who noted it. So we can say that Liu Hui finished it in 263 AD. And in this book, he left a lot of his great thoughts, like cyclotomy and overlap difference. Liu Hui used the cyclotomy, and he found that pi equals to 3.1416, uh, which was really accurate at that time. And he also used the overlap difference to measure large distance and length, like the height of a mountain or a distance from coast to coast. Um, that seems really hard at that time. However, Liu Hui did that. So now, uh, after have some point of view, after have some talk on history, let's have some real talk about math. So I'm going to uh, specially introduce cyclotomy and the overlap difference to you from Liu Hui. So cyclotomy is a way to get pi, or we can say it's a way to get the area of a circle. So Liu Hui said that we can make a inside hexagon um, inside the circle, and then we can obtain the area of the hexagon easily, and then we can divide it again, and we can have an area which is closer to the circle. If we repeat that steps uh, unlimitedly, we can get closer and closer to the area of the circle unlimitedly. Um, that's very alike to some other cyclotomy from other ancient mathematicians. Um, we've also learned some of them before, but as I read online, there were some different uh, from Liu Hui and others because Liu Hui's method is really neat and easy to understand. The second thing I want to, the second math method I want to introduce is the overlap difference. We can look at the picture on the right, which is the first problem in the chapter of overlap difference that Liu Hui talked about. Um, Here I wrote overlap difference, however, I found it in Chinese, but I didn't find a English translation for that method. So I just translated it by myself. So as we can see, this problem is really like the problems that we learned before, which is like um, your the length of your shadow when you stand under a light and you are uh, at some distance from the bottom of the light. Uh, they were really close, and even we can see that actually they're the same. However, at that time, uh, such a method have a huge meaning uh, in actual life, and Liu Hui was the first person who thought about, who came up with such an idea first. So such an idea was really great. Let's have a conclusion. So first, we looked at the decimalism and the counting system in ancient China that was founded really early. Then we looked at 9 branches of mathematics. So in ancient China, people divide the study of math into 9 branches. And then from those 9 branches, people, or we can say mathematicians, wrote the book 9 chapters on the mathematical art, which is really good, and people still use it today. People still research on it today. In the end, we talked about Liu Hui, the mathematician in the Three Kingdoms period, and he was the last mathematician who noted 9 chapters on the mathematical art. So we can see he finally done that in the end. So that's it. Thank you. Bye bye.